Okay, 2u plus 2v. First I need 1u, and then I need 2u. And this is 2u. And now I need 2v. So I have 1v, and then I have 2v. So 2v. I'm going to take my 2u and slide it on over. And it's going to be roughly here. This is 2u. Tip to tail. The resultant vector is this, which is 2u plus 2v. Problem number 2. Find the magnitude and direction angle of 6i plus 3j. Graph that triangle. Graph that vector. 6 this way, 3 this way. This vector is 6i 3j. This is the angle, and the angle equals inverse tangent of 3 over 6, and that's equal to 26.6 degrees. I need to find the magnitude. In component form, this vector is 6, 3. Its magnitude is the square root of 36 plus 9, which is equal to the square root of 45, which is equal to 3 times the square root of 5. Number 3, find a unit vector in the direction of u equals negative 6i plus 4j. Component form, this vector looks like this. Negative 6, 4. The magnitude of u, which is equal to the square root of 36 plus 16, which is equal to the square root of 52. This simplifies to 2 times the square root of 13. Now, the unit vector in the same direction is equal to 2 times the square root of 13 divided into each one of these components. So I'm going to take this and divide it into negative 6. So negative 6 divided by 2 times the square root of 13. And then 4 divided by 2 times the square root of 13. This simplifies to negative 3 over square root of 13 and 2 over square root of 13. Problem, that's the answer to number 3. Problem number 4 is a vector that is here, negative 6, negative 9. That's its initial point. 0, 8 is its terminal point. So I want to write this vector as a linear combination. So what I can do is subtract 0, take away negative 6. That's the first element. And the next one will be 8, take away negative 9. So it's going to be 6, 17, which translates to 6i plus 17j. That vector looks like this. This is 6, and this is 17. But here's your vector. Number 5. We want to solve this triangle. We're going to label this angle A, 50 degrees. We're going to label this angle B, 72 degrees. And we're going to call this C, 8. So we need to find all three angles and all three sides. So how do we solve this triangle? What we're going to do is use law of sines. So I'm going to find A first. So if you try to use law of cosines, it's not going to work. So I'm going to try to find A first. So I do A by writing the sine of 50 degrees over A equals the sine of C. Now C is not bad. I take 50 plus 72. Let's figure that out. Sorry. This is 112. Note 122. Take away 180 and I get 58 degrees. So the sine of 58 over 8. So A is equal to 8 times the sine of 50 divided by the sine of 58. So A is about 7.22. So we're going to put 7.2 in for A. We're going to put 8 in for C. And we're going to put in our angles here. So it's 50, 72, and 58. I still need to find angle B. So the sine of 72 over B. So I guess I'll do it over here. The sine 72 over B is equal to the sine of 58 over 8. Sine 58 over 8. So B is about 8.9. So 8.9. Number 6 is a problem that requires a triangle. Park ranger is at point A and observes a fire here, and another park ranger observes the same fire here. So this angle here is gotten from a compass. So north 25 degrees. I'm going to ignore this minutes here. We didn't study that. So we're just going to ignore those minutes for right now. So we're just going to go 25 degrees east, north 25 degrees east. So that fire is here. And this angle is 25 degrees. And over here, same fire. Is north 56 degrees west, so this angle is 56. Now my triangle here is created. This is 5 here, this is 34 here, and this is 65 here. So this is another side angle side, and we have to determine the distance from point B to the fire. So we have to find this x. So the sine of 65 over x equals, well, we need to figure out this angle here too. So 65 plus 34, which is 99. And if I take away 180, I get 81. So this is sine of 65 over x equals the sine of 81 over 5. So that distance is about 4.6. Okay. Find the component, problem number 7, find the component form of vector v. We're going to subtract the terminal from the initial. So we're going to get -3, take away 1, comma, -1 take away 4. So we're going to get -4, -5. Now that vector you can kind of see here, -4, -5, it's this vector there, -4, -5. So we want to determine the scalars here, so -3 times 4, -2, plus 3 times 3 comma 1, which is 12 comma -12 6, plus 9 3, which is equal to 21 comma 9. Find a unit vector in the direction of W. We need to find W's magnitude, and the magnitude of W is the square root of 36 plus 16. So it's the square root of 52. Now the square root of 52 is simplified to this 13 times 4, so it's 2 times the square root of 13. So we're going to get -6 over 2 times the square root of 13, comma -4 over 2 times the square root of 13. So this simplifies to -3 over square root of 13, comma -2 over square root of 13. That's a unit vector in the same direction as this vector. They're parallel. So find the vector v that has a magnitude of 6 and is in the same direction as u. I'm going to skip problem number 10. That was accidentally put on there. We can figure it out, but for the sake of time, we're going to move on to number 11. We're going to try to get this video done in 15 minutes. Well, I don't know if that's going to happen, but maybe 20. So actually what I'm going to do is stop